So I recently had some students complete some activities with transformations and connect those across statistics, cross those across geometry and cross functions, seeing how domains cross. Well, one of the things that I'm not sure it quite highlighted as well as I wanted it to was this connection of reflections and rotations and so on. So I wanted to just bring out real quick. So this is a graph of f of 2x plus 3. Now, if we were to put in f of negative of x, 2x plus 3, we would get negative 2x plus 3. So still the same y-intercept, but a negative slope. So down 2 over 1, down 2 over 1, down 2 over 1. Now, what's so cool about this is that it is a reflection. I'm going to try to show this to you with those georeflectors we have at the math collaborative. So again, if we put in the x value, it's negative, the function, which is the reflection. Let's say this thing to shape right now. Okay. Notice the reflector reflects onto the surface and right on top of it when it's right on the x-axis. So the reflective axis in certain negative x gives us on a function. The y-axis is the reflective line. Now, similarly, if you were to do the inverse of the function down here, which is swapping the x and the y, what becomes the line of reflection or what becomes rotation? Um, so traditional geometry, if you swap the y and x and put the negatives in, you see a rotation about the axis, which is a double flip. Um, and then you have to swap it twice, so it'd be negative x, negative y. But what about in the inverse? What becomes the line of reflection? So let's look, if we were to graph this, x over 2 and negative 3 halves. So there's my y-intercept, and the slope is up 1 over 2, 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 or down 1. All right, so let's the line on this one. And let's see where the line of reflection becomes. Here is the original 2x. Here, the new inverse of the function. I'll go ahead and label that. This is the inverse function. Where is this line of reflection? Right there, which is the y equals x line. So very cool connections.